In Chapter 1, it's all going to be about how we collect data in a reasonable way. So Section 1.1 is dealing with this idea that statistics is about variability. So we're going to have all of these statistical methods that are going to help us collect and describe, analyze, and draw conclusions from data. We're going to be spending the rest of the semester learning about how we do all of that. So why do we have this field of statistics? Well, if you consider things in the world around you, very infrequently are things exactly the same. People have different heights, different eye colors. You pay a different amount of money at the gas pump almost every time you go to fill up. And so this idea of variability occurs everywhere. And so statistics is going to help us understand that variability and help us determine how a sample can be used to describe the population if we understand how this variability works. So consider that we have somebody studying a population of students, and it would be really difficult for us to get data from all of the students all across the United States. There's millions of them. But if we took a smaller sample, that would be more manageable, and we could take the sample, and if we understood the way that the students varied, then we would be able to estimate different things about the population from the sample. That's the idea of statistics, taking a sample and using it to describe a population. We have an example here where, as part of a regular water quality monitoring effort, an environmental control board selects 5 specimens from a particular well each day. So they go to this well and they calculate or measure the concentration of contaminants in parts per million for each of these 5 specimens. And then at the end of the day, they take these 5 measurements and they average them. So you'll be learning in Chapter 2 about this graph that you see, but it's called a histogram, and it's a way for us to plot the frequency for the different measurements that we obtained. So you're looking at 200 days of these average contamination levels. You'll see that there in the middle, most of the data is there around between 12 and 16 parts per million. So if you wanted to consider a typical measurement, then I would say typically you would find a measurement between about 12 and 16. But in statistics, we want to consider this idea of what would be something that's unusual. So if there was a chemical spill that occurred at a manufacturing plant 1 mile away from the well, and we wanted to determine if the spill would contaminate the groundwater in the area. So we have these measurements from this well of what should be happening. There's certainly plenty of variation that's occurring from day to day, but we would be able to determine if this chemical spill made something unusual happen. So if a month after the spill, the measurement was 15.5, if you look at that histogram, 15.5 really is not that unusual of a measurement. We saw values close to 15.5 plenty of times. So you would not expect that anything strange was happening. But let's say instead you got a measurement of 17.7. Well, 17.7 is getting a little more unusual because you can see from our graph that we did not see that kind of measurement very frequently. And even more surprising is if we got a measurement of, say, 22.3. In our 200 days, we never saw something as large as 22.3. So if that was our measurement, then we would say something here is happening because that is just so different from what we would expect to see that there must be something else that's affecting this. And that's going to provide the logic for a lot of what we do in this class. We collect data from a sample. We know what the population should be. And if we get a value that's very different from that, then we'll know that there's probably something else going on.